is I'm gonna draw just a little sketch. I'm gonna grab 3 to the x in blue.
-2?
No,
Just 2?
no, that's square stuff. Square root.
This is number 13.
Yes. Yes.
What happened?
One, there we go. Okay. So as I'm writing this, instead of that square root, I'm going to put 1/2 power out here. And then if I have power to power, what do I do with those two? Multiply. Now there's like a couple routes you could go here. So I'm going to take one way and then show you the other. You could say this equals something, right? And then so you say e to what power equals 1/e to the 11/2. Well, Josh, what would flip it? What would make this go down to the bottom?
It would have to be a -1.
It would have to be a negative in general, and then it would need to be exactly that power, right, to make it be on the bottom like that. So one way you could look at it would be like that. Does that make any sense? Another way, you could also do this. You could rewrite that with a negative power. You follow that? Then you could say, oh, those cancel out, right? So therefore the answer is -11/2. So either way. I'll get you there. Okay, anything else on that page? Okay, 17 through 23. So as I'm writing it down, I'm going to write the square root as the 1/2 power. So the main rule at work here first would be division. So I'll show you the steps. You may not need to do them all. But so first you would split it up with division. which means you can subtract the logs. And then here, because they're being multiplied, you can split that up with addition. So log base 19 of 5 plus, and then that 1/2 would become the coefficient. Does that make sense? That whole next page is just chock full of log rules. I know the other class wanted to see 31 and 32. Do you want to see those? Or,
Can we do number 17?
yeah. That's just our canceling out business. So because these match, that'll just be 20.
Oh, okay.
Which also works on like number 20 as well. That one's the same. Anything else on that page? Okay, so I'm gonna do 31, 32 for sure on the next page. By the way, what's a common log? Base 10. So we had, let me remind you of the change of base. Change of base rule. This was when you had to take some notes on your own. I wasn't here for that half day. Change of base says you can rewrite any log with any base you want. So it says this could become log base b of x, so this number over log base b of that number of base. So in 31, they're telling you to use base 10. So you have log. That's the most distracting hack. Okay. Okay, so for this one, it says use base 10. So it's going to be log base 10 of x plus y over log base 10 of 4. Yeah, it's got to go. I'm sorry, Paul.
Why?
It's just too much. Sorry, I might not have been trying to fix it. But
It was driving me nuts. I love the hat.
Can't take that.
Okay, so that's it for 31. Notice you don't need to write base 10 or something. Now when you get to 32, it says, hey, use natural logs. Okay. So you have log base 1/4 of a minus b. So you say, okay, that needs to be natural log of a minus b over natural log of 4. Now, is that one of the choices? What do we do?
Do -1 exponent -1 equal 1 4 -1 is 1/4. So you can move that -1 to the front, and then that would just make it.
Beautiful. Okay, so Nick says you could rewrite 1/4 as 4 to the -1st. That's legit. And then you have the top. You don't do anything. You don't do anything with the top. Then by the power rule, all is well. Did anybody think of a different way? Of a different rule? I love that. I think most people like it, but just for fun. Is this not natural log of 1 minus natural log of 4? By a quotient rule? This part, just this part. And what's natural log of 1? 0. Whoa. Which gets you there too. It's just a different way, you know? Nick took this road, I took that road, we got to the same place. It is funny. I like that problem. Okay, anything else on that page? Ooh, and then the back. 33 through 41, there's lots of good ones there. You don't pick, I will. Abby?
34.
Yes, thank you. Okay, so in general, let's just talk about the process of finding domain. Finding the domain of a log, we do what with what?
Then she said, like, see what's in the parentheses for this question. Greater than 0.
Perfect. So because we know log of negative is no good, we know that this needs to happen. That should be your first thought for domain of a log. And then we would want to go about solving it. So I'm going to add x squared over. So I'm looking to find what kind of numbers squared are less than 64. So what's the square root of 64? 8, and I heard plus or minus. Good. So let's kind of go through the cases. Let's start over here with our positive numbers that we like a 9. Would be over here, right? If I square 9, is that going to be less than 64? No. These numbers are not any good. With me?
Yeah.
Let's skip over here, because the same situation. If I were to square like a negative 9, will that work? Give me a friendly number in there.
0.
6 works too. If I like 0 because it's easier. If I square 0, is that less than 64?
Yeah.
How about 6 for Abby?
Yeah.
Yes. There's your domain, the happy place, right?
Yeah.
Negative 8 is 8. Better?
When is your sign gonna be like greater than or equal to? When's the equal to number?
Never for a log.
Okay.
Yeah. Did they throw some?
There's brackets on that. There's brackets in the one options.
Oh, yes, because you can't, so we also had, sorry, that the log of 0 is no good either. Because you can't raise like a 10 to a power and get 0. So I would just, if I were you, I would cross out any brackets when you take this test.
Yes.
I would like to do 35 and 36.
Because I don't know.
Because they're two good log equations, but they're different types. Oh, and so I'm going to see how there's 2 logs and then a number. So the logs should be together. So I'm going to add log x over. But I'm going to keep the 1 on the right. So I would like to bring these together. How can they be brought together? Okay. So I'm going to go ahead and do x times x plus 3. So that's x squared plus 3x. Now I want to, and this is, I feel like the earlier class felt like this was magic, so I don't want to gloss over it. What's this base?
10.
So rewrite it as exponential. 10 to the first equals x squared plus 3x, right? And I say rewrite as an exponential. What? That's not right. You with me? And there's just a happy quadratic, right? We like them. So I will make sure they do factor and they're not gross answers.
Thank you, Mrs. Mikey.
I knew it's going to be used.
What's that? I know.
know.
He's a little predictable now. And just polite, but not.
Thank you, Mrs. Mikey.
Oh my gosh.
Okay, so now you're gonna pick, where is it? So it's B, right?
Yeah.
No. It's B.
No.
Why not, Brian?
I'm trying to do it.
Why not? This into there is not a good thing. That is very bad. Now the 2 is okay. So we'll keep the 2, we'll get rid of the negative 5. Don't be like that. Okay, let's do 36. Somebody having fun saying that word today?
What?
Yellow.
What am I doing?
Saying extreme.
Over and over.
I said it 3 times.
Yeah,
Strange.
I think 3 is enough.
Well, when you said it just now, I stopped saying it.
Okay, what did I do?
The other two.
I did the product rule. Now, why is this problem different than the one we just did? There's logs on both sides. No constant, right? So what do we do?
Can you just do chop up the
Chop them out. I like the use of the word chop too. I see what you did there. Right? Chopping.
That was unintentional, but I like that too.
Okay. I want to make clear, you're not just getting rid of the logs, you're using the fact that bases are equal, then the inside should be equal. Yes?
Yes, always.
All good? So in a way, I think that's almost easier than the previous problem, because you don't even have to rewrite it, but. So subtract 5x divided by -2. Does 5 work when you plug it back in? Does not create a negative in any way, so we're good with that. Anything else on that page before we do a little bit extra review? Oh, that's it. Flip to the calculator part. There was a typo on the answer page.
Yes, calc answer page. Right here, oh, that's not the answer page.
On the answer page to the calc part, the answer is, for 1, it should be C. And then I wanted to do one of those with you. Go to 4. I have it over here, but I'm gonna rewrite it. Four requires a little bit of reading comprehension. The actual math, you can do it. It's just we need to be clear what's going on. So go ahead and read 4 on the calculator part
This one,
if you haven't yet.
right here. Just read it, Paul.
Okay, so a couple of things. So I is your initial amount. And so it's kind of, doesn't this kind of look like Kurt? Remember
Yeah.
Kurt? We're gonna talk about that in a minute again. But, so I is your initial amount, or like P in Kurt. And you have 67% of it remaining. Okay. So we don't actually have the amount, but we know 67% is left. So if I call this I, how could I represent 67% of I left? 0.67 I. Makes sense. So I started with I now have 67% of it left, or 0.67 I. E comes for free. And then that K, now be careful. See how it says 0.0125%?
Yeah.
But I need to change that to a decimal. How many zeros total? 3. And because it's negative, or because it's decaying, we need to take it to be negative.
Okay.
Is the setup okay? Yeah. And we need to solve for t. So let's divide by I. So when we do that, the i's will cancel out. Oops, got my equal sign here. Now, to solve this, what do we do to both sides? Natural log. And remember, the beauty of that is the natural log of E is 1. So therefore, you only have this number times t on the right. So grab a calculator and take natural log of 0.67 and divide by that tiny number there.
You gonna do that or?
Did you get, what did you get? 3204?
Yeah. The answer is 3.
Okay. So, I did post the actual worked out problems today. And I did move the test back a day. It's now Wednesday. Okay? So, we're gonna do a couple things, okay? I want you to flip to the back. You have a whole white page. First, we're gonna talk about the format of the test. Then we're gonna do a couple review problems for tomorrow, and then you should have a little bit of time to keep working. The format of the test: 20 multiple choice without your calculator, 18 with your calculator, and then 2 problems with these 2 formulas. Remember, I didn't give you homework on these, because all it is just boop, boop, boop in your calculator, okay? But we're gonna practice 2 of them right now. So I would write this down so you can look it over. So I will give you these, you just need to know which one to use where. Give me a second to write this down. They're in your 3-6 notes as well. Okay. So here's a scenario. What if I said you started with $500, your rate was 5%, so 0.05, and 10 years. Oops. There we go. Compute the final amount when you're compounding quarterly and when you're compounding continuously. Now,
What does continuously mean?
if you see that word, you automatically use which one?
Oh, with the bottom.
Yeah, per and continuously.
What was like the K mean? God, I forget. What's the K variable mean? I forget.
Class, what's K mean? Like in this case, quarterly, what's K?
4.
It's how many times per year. So if I said monthly,
That's what I thought.
12, okay? So write the setup down for yourself and then type it in.
God, what's P?
P is the starting amount.
So
That's the
500.
Yep.
Thought so. And what's R? Oh, T is 10.
KT, so K is 4. This is your, I don't know. So K is 4, right? And then all the other numbers are given. So here's the setup. So 500, 1 plus R over K. K times T is 40. And you should get 821. And then continuously, same idea, same numbers, just a different formula. 500 e to the 0.05 times t gives you 824.36.
Okay, now how the heck do we solve this? Oh,
All you do is type that in your calculator.
I get this.
Okay? Those should be 2 very easy questions, right? All you have to do is type in this. Alright, and the last thing we're gonna do, same on the back of your page. Tomorrow I'm gonna give you just a little 4-question checkpoint over log and exponential equations. So we're gonna do 4 questions right now to practice. Okay? Okay, so here's it's kind of bold. Okay, here's 1 and 2. So you're gonna solve these. These are practice for the little quiz tomorrow. Let's just do one at a time. Just start with 1 and I'll check it. Is that on the door?
Yeah, no, it's not like.
If I say good, you can do the second. If you got 2 11s, you can move on to number 2. If not, I'll kneel them. Anybody need help with number 1?
I would have.
So get rid of that. So what power, so we want to write these 3. So 27 can be rewritten as 3 to what power? Yep, and then we copy the left side. Yeah, it's just that x plus 2, you can solve that x. Yes, solve it now, solve it. I can't remember this right. Yeah, that's fine. Get 2 11s? No.
I think I screwed up with like.
This doesn't.
Oh. I really want this.
This side was good to go.
Oh.
This side.
Oh. Oh.
Okay, there's number 1.
Okay, now I see. I was doing the opposite.
Yeah. Okay, number 2, what'd you get? 3. So number 2, I threw that in there. Hopefully you weren't, some of you might have been tempted, but you didn't, right? You did not multiply these, that's not a 2. Okay. You divide by 3. And then you're like, oh look, they match. Cool. Okay. And this is a power of 1. So x minus 2 is 1, so x is 2.
Thank you, Mrs.
So those are the 2 exponential type. And then there's gonna be 2 log equations. I know something. Okay, and then here's, this is without a calculator,
Uh-huh.
so you can leave your answer in terms of D.
Yeah, sorry, like, I understand the work.
Yeah, but that doesn't mean you don't have to follow along.
Mm-hmm.
Wait, is that?
So that's natural log of x plus 3 equals negative 1.
I got x equals 2 over 11.
Yeah, that's right.
Oh, I thought it was 11 halves.
So are you writing it as an exponential?
Do that one more quick so you can say God.
Now, notice I wouldn't, that E was left over from
X
last
plus
class. I wouldn't have
ln
put
x
that in
plus
there. It
3.
wouldn't be written like that to start. You would need to know that it was base E. You can.
Make this, that's like, so you should explain that to users.
Oh.
Like,
Wait.
I know.
So a couple ways your answer can be written. So rewrite e to the negative first is x plus 3. Subtract 3. So you could leave it like that. Or you could rewrite it as 1 over e minus. Good deal?
Yes.
And again, I should have, this will not be here, you need to know that that's E. Okay. And then one more.
Calculator.
No calculator. Don't need it. Solve for x.
Okay, all you doing?
4 is. Oh, we're on this one.
This is the last one. This is the one where she said just 2 long people. So close. This will be times. Oh, okay. Gotcha. I gotta do that.
No.
Which makes sense. So then so yeah. Don't forget to check your answer. Plug it back in, see if it works. Well, you should still plug it in. Like, what if that was longer? I don't just want to say because like. Most of the time. Okay. All right, so product rule brings them together. And then because they're both log base 10, you can set that inside's equal. You get -8/3, but wait. -8/3 plugged back in is no good. So that's what to expect tomorrow. All right, Wednesday's the test. Tomorrow we'll do a little review bingo, which is always fun, and our quiz. Make sure you check the website. All of these are worked out. So you still have about 11 minutes to keep working on your review.
Okay.
Yeah.
So I sent an email out. That's my, yeah, I only got one response. Who's available next semester. So I haven't had anybody for this second one yet.
I always
So did Emma start? Yeah, and it's safe. Yeah, no, I did. So, just go from there, maybe I'll have. I think it's coming back.
Okay.
So I'm working.
I just.
Give me a couple more days. I'm not gonna done with figures. Thank you. So like, I was here next. This is growth. And I made another one. So then these two.
Paul's gonna work on that or
Choose
not?
the one alternative that best completes the statement or answer.
You don't have to read it out loud, Paul.
I can never put holes in my paper.
Alright.
The base is. That was description. And really, which is a point. So what is